Okay, so we're going to start our foldable with our four variables. We have pressure with a capital P, volume with a capital V, temperature with a capital T, and then the number of moles with a lowercase n. So these are the four variables that are going to affect a gas. So we're going to talk about each one of them sort of individually. Let's start with pressure. So pressure is caused by gas particles colliding with the wall of the container. Okay, so the more times a gas particle hits the wall of the container, the greater the pressure it's going to be. So let's make this real short. More collisions is equal to a higher pressure. Okay, pressure is measured with a barometer. Okay, so we can measure pressure. We use a tool called a barometer to do that. The problem with pressure is, oh my goodness, it has so many different units that we could use. We have a unit called atmospheres, ATM. Sorry, let me zoom that a little bit. There we go. Then we have millimeters of mercury, and that's literally like how high up a tube it goes. We have torr. Sorry, that's a 6. Okay. We have kilopascals. That's our, oops, that's a K. Kilopascals. And then we have PSI. Anybody who's ever worked on cars or worked with pneumatic tools knows that PSI stands for pounds per square inch. Okay, and then we also have inches of mercury. All right, so what if you are measuring your pressure in atmospheres, but then you need it in torr? So we're going to use dimensional analysis to go from one to the other. So remember, when we're doing dimensional analysis, the given goes top left with units. So let's say we measured our pressure to be 2.3 atmospheres. Okay, and we want to know how many torr that is. All right, so rule number 2, top left matches bottom right in units. So we're going to drop that atmospheres down. The unit we're trying to get to is torr. Now, look at this. This is one big giant equality. Any two of these things can be equal. So I know that for every 1 atmosphere, there are 760 torr. So I'm just going to take the 1 that's next to atmosphere, put it next to atmospheres, the 760 that's next to torr, and put that next to torr. Okay? So our atmospheres will cancel out. And remember, when we're doing this, we just want to multiply across the top and then divide the top by the bottom. So I'm going to do 2.3 times 760 divided by 1. That's going to get us a pressure of 1,748. Rounding to 2 sig figs, that would be 1,700 torr. Okay? So we can do that with any of these units. So if I'm in PSI and I want to go to kilopascals, I'm going to use this equality in the grid. Okay? So that's how we can convert between different pressure units. The next one is volume. Volume is the space that the particles are occupying. Now remember, the particles themselves are not taking up space, but they are taking up space by moving within a space. All right, so we assume that the particles themselves don't take up space, but that they are creating a space needed by their movement. So this is based on the movement of the particles. Okay. So volume can be measured a number of different ways. Typically, we will measure volume in like a graduated cylinder. And so you ask me, Miss Crane, how do we measure a gas in a graduated cylinder? It's not going to stay in the graduated cylinder. Usually when we're measuring a gas in a graduated cylinder, we would do it by water displacement. So we would fill the graduated cylinder with water and invert it so that the water has like a bucket of water underneath it. And we would bubble the gas into the graduated cylinder through the water. So it's actually pushing the water out as the graduated cylinder fills up with gas. So we can actually use a graduated cylinder to measure volume of our gas using water displacement. Okay. Units for volume. Volume has several different units. We can measure it in liters. Okay. So 1 liter is equal to 1,000 milliliters. That's the other one we most commonly see. And then sometimes we will see centimeters cubed. Okay, 1 centimeter cubed is the same thing as a milliliter. So the most common one, though, is you're going to see this first one. So oftentimes we'll say you have 250 milliliters of gas, and we want to convert that to liters. So we're going to use our grid to go from milliliters to liters. There's 1,000 milliliters in every 1 liter. So we would take 250 divided by 1,000, and that gets us 0.250 liters. So we can also go the other way. Like if I had 1.3 liters and I wanted to go from liters to milliliters, there's 1,000 milliliters for every 1 liter. So if I do that, this time I'd be multiplying by 1,000 instead of dividing by 1,000. So I do my 1.3 times 1,000, and that's going to give me 1,300 milliliters. Okay. Let's talk temperature. Temperature is directly related to kinetic energy. So in this case, we use our temperature to determine how fast the particles are moving. Typically, we measure this with a thermometer or a temperature probe. We do have some fun temperature probes that allow us to do some interesting stuff with our graphs. I mean, you'll see that when we do our gas laws lab. We've got some fun things that we can do with those temperature probes. All right, so temperature has basically 3 scales. We have the Fahrenheit scale in degrees Fahrenheit. We never use that one. Yuck. Okay, there's degrees Celsius. This is the one that is typically the one that we find on our lab thermometers. All of our lab thermometers are going to measure in degrees Celsius. And then the last one is the Kelvin scale. Kelvin is based on the concept of absolute zero. A temperature where there is no energy. So basically, you're never going to get to 0, and you're never going to have a negative number with Kelvin. When you're doing gas law calculations, all temperatures must be in Kelvin every time. So if we measure in Celsius, how do we get to Kelvin? We take our degrees Celsius plus 273, and that's going to give us our Kelvin value. If we're in Kelvin and we want to get back to degrees Celsius, we're going to subtract 273, and that's going to give us our degrees Celsius. Okay? Please note that Kelvin doesn't have a degrees. It's degrees Fahrenheit, degrees Celsius, and then just Kelvin. Okay? The last one is the number of moles. This just tells us how much gas, or to be more specific, how many particles of gas do we have? Now, here's the important part. We don't have a tool to measure moles. So this number will usually be given in grams. So this is where you're going to use your grid, and you're going to take your grams of gas, and you're going to convert it to moles of gas. Okay, so 1 mole is going to be equal to the molar mass of your gas. All right, so for example, a very common gas we would produce is carbon dioxide. Let's say we had 21.3 grams of CO2. We would go from grams of CO2 to moles of CO2. For every 1 mole of CO2, we would get the molar mass of CO2. So we would take our mass of carbon, 12.011, plus 2 times the mass of oxygen, because there's 2 oxygens, 15.999. That gives us 44.009. So our grams will cancel, leaving us with moles. So 21.3 divided by 44.009 gives us 0.484 moles of CO2. Okay? So these are the variables that you're going to have to be able to go between when you're working with the gas laws.